see. So now we're going to hand over to Steve Waterworth, who's going to talk about Instana and the challenges around understanding the performance of your microservices infrastructure and the challenge of monitoring it as it keeps changing as well. So,
okay.
Over to you, Steve.
Hi. So yeah, Kubernetes, it's all Greek to me. Although it's a little bit trivia for those of you that don't know, Kubernetes is in fact Greek for helmsman. So that's where that comes from. So this is me, currently Technical Marketing Manager at Instana, previously with AppDynamics, Quest Software and Wiley Technology, so I've been knocking around the APM space for quite a while. Prior to that, I have a development background, and I still like to play around with stuff like that, coding on Arduinos and the like, so still doing that. So Kubernetes then, we've heard quite a bit about it. So a little summary, the good, the bad and the ugly parts of Kubernetes. The good part is it makes life so much easier for deploying containerized applications. All the boring stuff is taken care of for you with Kubernetes. You say, hey, I need 6 Nginx's, and you get 6 Nginx's. Should one fail, it'll just create you another one. And it'll keep going. It handles all the networking, all the load balancing, everything for you. So fantastic piece of automation for running a containerized application. The bad part, as we've heard, yeah, it does add quite a bit of complexity. There's a whole bunch of moving parts inside Kubernetes that you need to manage, or you get the best way, of course, is get someone like Platform 9 to do that for you. It's you really don't want to be doing that yourself. I have built a Kubernetes cluster from scratch just because I'm a bit of a masochist like that, and yeah, it's long drawn out and painful, and should anything go wrong, oh dear. There's a lot to debug should it go wrong. The ugly part of Kubernetes, yeah, it's YAML. If you do anything with Kubernetes, you will be editing a lot of YAML files, and it's truly horrible. 2 spaces only. Don't get that bit wrong. So that's the ugly part of Kubernetes. So, why go to containers anyway? I think some of the previous speakers have touched on that. And really, it's about velocity. The CI/CD pipeline, where the faster you can get new features and fixes out the door, the better. The more competitive your business is. It's a business-driven thing. You want to get that new functionality fixes out the door as quickly as possible, and in order to do that, we adopted techniques like Agile, DevOps, CI/CD, and then as an enabler for that, the technology is cloud containers and microservices, and all of that then gives you the speed. But because there's a little bit of a paradox in that the monitoring part, the observe part of that loop is more important, because without controlling feedback, instability is inevitable, and quality will fail. So whilst it's more important than ever to be monitoring, it is also more difficult than ever to be monitoring, because everything's changing all the time. You're trying to hit a moving target. So these are the monitoring challenges you have with the Kubernetes environment. First of all, don't forget to monitor Kubernetes. If that breaks, you're screwed. So there's many moving parts there. So when you consider your monitoring solution, you need to think about, how do I ensure that the Kubernetes is healthy? But you've also got to include that monitoring in that CI/CD pipeline. You've got to maintain that velocity. So how do you ensure that your code is observable? If you're building the dashboards, those dashboards have got to be released in sync with new functionality, so that you can actually see what you're looking at. And then same thing with health rules. It's all very well releasing new versions of code, but if those parameters change radically, or there's new metrics that need to be monitored, then you've got to have that CI/CD in place for those. Now, one possible solution to that is, going through the CNCF. I think it was, I can't remember who it was. Somebody showed that like periodic chart. There's a whole bunch of open source stuff that will help you. and you can build monitoring as code or observability, as is the buzzword at the moment, which is, hey, don't go agent-based, build the monitoring into your code. Prometheus is the weapon of choice for that, to give you your application metrics, and then using Jaeger for distributed tracing. Prometheus and Jaeger. So Prometheus, for those of you that don't know, is a time series metrics database. It has many exporters in there. It has client APIs, so you can expose your own custom metrics, and it will expose metrics for your language runtimes. Some components also automatically already have a Prometheus endpoint built in. Jaeger, based on open tracing, which is sort of morphing into open telemetry at the moment, merging with open census. So the whole area is a little unstable at the moment, but you use their API to instrument your codes. Again, it's manual code instrumentation, and if you're running Jaeger, you require a big Cassandra cluster, so you're going to have to stand up, manage and maintain a non-trivial Cassandra cluster. With, I forgot to mention, with Prometheus, you have a monolithic Prometheus backend which only scales vertically. So if you're going to have a lot of Prometheus metrics, you're going to need a very big box to run that. But this is really only a partial solution. You're really taking development time away from developing core functionality to developing a monitoring solution. And it really doesn't solve the problem for how you keep your dashboards and your health rules up to date. And in the end, what you ultimately end up with is two disconnected buckets of data. You end up with a large bucket with a bunch of traces in it, and a large bucket with a bunch of time series metrics in it, and no linking between the two. You can't easily go from a trace to some time series metrics and time series metrics back to a trace. There's really nothing there to manage alert storms. So this is one of the downsides of a microservices application, because you have a huge web of interconnected services. Should one thing break downstream, the ripple effect can be a bit of a tsunami, and you end up then with a whole, with hundreds of upstream alerts being triggered because a data store is slow or unavailable. So you need a way of managing how that alerting works, and really you're not monitoring, you're just collecting data. If you're just collecting a bunch of Jaeger traces and a bunch of time series metrics, all you're doing is just drowning yourself in data. So as an example of this is a mid-sized customer of ours. They're running 166 servers, about 10,000 containers across those. That's a density of about 60 containers per host, which is a bit higher than normal, but certainly entirely possible. That gives them about 310,000 time series metrics, and a whole bunch of traces as well. So if you take the SRE recommendation of 5 metrics per graph, 5 graphs per dashboard, that'll give you 62,000 dashboards. Now, if you've got nothing better to do with your time and you spend 8 hours a day looking at each dashboard for a minute, that will take you 129 days. So as you can see, the amount of data you're trying to consume is just too much, way beyond the capacity for a human brain. It is getting the drink from a fire hose. So really, you shouldn't just be staring at metrics. You need a more intelligent way of doing it, and this is where Instana comes in. We need some level of automation there. Kubernetes is this huge automation engine for running your containers. It does a bunch of stuff under the covers for you. So you should apply some level of automation to your monitoring. Now, if we take an example from a different industry here, then my colleague here will like this. If you used to do flight simulations and things, this is a civil airliner. This is the flight deck from an older 747. There used to be 3 crew on board, captain, first officer, and an engineer. And this is essentially, if you're trying to build something with Prometheus and Jaeger, you're essentially trying to build something like this, which is a bit overwhelming you with data. And this is a modern 747 cockpit. We've lost a member of crew. We no longer have an engineer. We just have the the captain and the first officer, and as you can see, a whole bunch of that stuff has been shrunk down to essentially 3 screens. And the automation behind there is going to pop up and tell you what you need to know. You don't have to try and find the appropriate gauge and stare at all those gauges. So as we said, data is not information. Observation is measuring, monitoring is essentially paying attention, and really effective monitoring really needs an organised memory. There's got to be a coherent model behind that data. Just having a big bucket of data doesn't help you. So the concept is really what we do with Instana is we take all that data, we take traces, time series metrics, CloudWatch, logs, and put it through Stan's immense brain, and what he's going to give you is actionable information, and that information is going to be, tell me what I need to fix now, what's broken, what things are going wrong that Kubernetes hasn't self-healed, and tell me what can be optimized. Tell me where things, maybe an error rate's a bit higher than it should be, or things are a little slower than they should be. It's not broken, but it's just suboptimal. So it's going to give you that level of information. So how does Instana do this? So we have automatic discovery and observability. So in a Kubernetes environment, our agent goes out as a daemon set, so that ensures there's one agent running per worker node inside Kubernetes. And what that agent is doing is constantly seeing what else is running on that worker node. So as loads are scheduled onto it, or scaled onto it, or failed over onto it, it's going to say, hey, I've got a new process. It then does process fingerprinting, figuring out what that process is, and then starts, once it works out what it is, it'll start monitoring it, or collecting the data. It gives us immediate feedback. We're trying to get around this loop as fast as possible. The leading practitioners in here are doing multiple deployments per day. So when you hit that deploy button, you want to know fairly quickly whether it's a good one or not. And then you can make a rapid decision whether to continue and let that deployment continue to roll out, or hit the eject button and roll it back before anybody notices, hopefully, or before there's too much of an impact. And because we can do that with canary testing as well, it doesn't have to be a full-on deployment. So Instana gives you 1 second metric granularity, every request traced, and only a few seconds delay from real time. So you're getting that data on your dashboard a few seconds behind real time. And if you decide after just a minute or two to roll it back, because we've got that high density of data, there's plenty of information then for a post-mortem. Automatic root cause analysis. So this is where having an intelligent data model. So what we have at the heart of Instana is a thing called the dynamic graph. So this keeps a track of entity relationships over time. So it knows what's running where, what's talking to what at any point in time. So if we go back to my original example, say we have a data store that becomes unavailable or suffers poor performance, and it has this massive ripple effect through, and you may be getting 50 separate alerts out, but because Instana understands how everything's interconnected and the flow, it can do that cause and effect analysis for you. So what you'll actually get from Instana is one alert saying this data store is slow and it's causing this ripple effect. All these other services are suffering as a result. But essentially it says, go fix that data store. Go find out why that data store is not working properly and go fix it. And then application perspectives. As we've said, a microservices application can easily contain hundreds, if not thousands, of microservices. You're working on a development team and you're maybe responsible for the payment gateway. There's a handful of services that is your world. You don't want to go fishing around through a few thousand other services looking for the thing that you want to work on. This is where application perspectives comes in. You can create your own view into that microservices world, and it's tag based. So as things are deployed, scaled, as long as the tags match, it'll come into your perspective. If they're deleted, then they'll go out of your perspective. So each team can have their own application perspective or many perspectives. And then unbounded analytics. So we automatically collect all the tags from everything, so all the Kubernetes labels and annotations, same thing on Docker, same thing on the host. All that metadata is collected and indexed, and same thing on the traces, all the information that comes through on a trace, all that again is collected and indexed. So you can then easily search through all of that to find anything you want, cross-cut that data any way you want, and it's all done with a nice simple point-and-click interface. No need to learn yet another domain-specific language to be able to find the piece of information you're looking for. So the final sort of thoughts on that is really, what we're attempting to do now with microservices and the complex world of Kubernetes. It needs a different way of looking at things. Back in the old days when you just had the one mainframe, or maybe or a couple of Linux or it's probably Sun or something like that, or HPUX servers, you sort of knew where to look straight away, and there was only two of them, so you sort of loved, cherished, and cared for them. Now, with the microservice application, you've got potentially thousands of little applications, loads of them. You can't care for each one, in the same way as you could used to care for your big servers. So it's much more of a cattle versus pet attitude to looking after the health. And of course, Kubernetes is going to take care of its basic needs. If one of them dies, it'll just create another one. If a worker node dies, it'll just migrate the load across. So all that stuff is just happening automatically. Kubernetes is doing that for you. So you're much more interested in the health of the herd rather than the individual component parts. So just don't sweat the details. Relax. Look at it at a higher level. And you've got to make sure that the monitoring solution you choose to go with is not a bottleneck. The whole point of going to containers is to get that speed, and because you're only ever as fast as the slowest step. So if you're manually instrumenting code and manually managing a bunch of health rules and manually having to keep dashboards up to date so all the information's in the right place and the drill downs go to the right place, it's slow. It's not as fast as it could be. So don't slow down. Let the robot do the work for you. And one of the reasons I'm sitting here is because I was asked to quickly show the product, so I've just got a few minutes left on my time to do that. So, if I find where my mouse has gone, there it is. So what I have here is just something I've been playing with recently. This is running on GKE. So this is a little Kubernetes environment, as 4 worker nodes inside GKE. It's running Stan's Robot Shop, our sample microservices application, which is free. It's all on GitHub. You can have a little play with that if you want something to play with. And you see right at the top level here we have a Kubernetes tab. All your clusters will be listed here. I think they've only got the one. So all this is all auto-discovered. The agent's deployed with a Helm chart. Just a Helm install. Go, all the auto-discovery happens, all this information will start coming back. So you've got your Kubernetes dashboard here with a summary of the dashboard, of your environment, all your different namespaces, what we've got deployed in there. I've got a Splunk instance running in here as well. This is Robot Shop itself. It has 12 deployments, so there's some language runtimes and some other infrastructure components there, such as MySQL, MongoDB, RabbitMQ, etc. We have the services that go with that. So services is like the network endpoint in Kubernetes. Generally it's a one-to-one mapping, but that doesn't have to be. That's probably getting a bit advanced at the moment. And we can look at the service, and the service then shows us, it's on a cluster IP, and these are the target pods. There's only one pod in my replica at the moment. And again, this is where this dynamic graph comes in. So this is looking at it from a Kubernetes point of view, because there is an endpoint there that's being called. So this actually relates through then to our payment service, and now this is the logical service. So this is essentially the traffic that is running through that. So this is the trace data, and what we do then is analyse that trace data, so we're getting our top level view here of the calls that are going through, and you can see we've got quite a high error rate. This is deliberate, so that you've got, so I can show you some errors. We can see the flow for that, so we get a good view of immediately what's upstream and downstream. There we go. There's nothing upstream, so this is an entry point, and then it uses various downstream services. I think this only has the one endpoint, if I remember correctly. Yes, this only has one endpoint. We've got a bunch of errors happening, so we've captured this from the logs. So what we're doing is instrumenting the loggers. So this is a Python app, as you can see. So the Python logging framework has been instrumented. So we're collecting from 1 and above directly, so without any, with zero work. And if I drill down on that, then we get to the traces. So there's then a whole bunch of traces where that error happened. I can look at one of those traces. And now we see end to end, so we see that it comes in from outside, hits this point. We get the infrastructure view because of the dynamic graph. We know where everything is, the relationship to everything. So not just what calls what, but also where it's running. And we have our error, which is this none-type object is not iterable, and that happened in our payment bit of code, and we can see, get a view of our code. This also works for Java as well, although that's compiled, we decompile on the fly. For these sort of scripting type languages, of course, we can just pull the file back. So you can get a sneaky peek here and go, oh, right, yeah, and see what I need to go fix the code, push that into your Git repo, your CI/CD pipeline will do an automatic deploy, and then going back to your payment view, you would see then, I haven't got it set up in here, but you'd get a deployment marker appearing on the timeline, and then downstream of that you'd see straight away whether that had been fixed or not. So you get that immediate feedback that yes, I've fixed it, that's good, my life is good. So that's a very quick whiz through. Any questions? They all stunned.
So it starts doing APM. What about infrastructure monitoring? Will it provide some level of
yeah.
for that?
Provides loads of infrastructure detail here. So if I take a look from this service, I go back to the container. So now we're looking at infrastructure metrics for the container. So we've got our Docker container here, which is running in a pod on the Kubernetes node, which is then actually a GKE host instance. So therefore you've then got your host level information, so we can see what our CPU, disk I/O, memory, etc. is doing. And again, there's a whole load of built-in intelligence, so all the standard sort of alerts you would expect, they're already in there. We have a curated knowledge base, so if you pin your CPU, you're going to get notified. If you run out of memory, you're going to get notified. If the disk starts thrashing, you're going to get notified. You get too many TCP drops or retransmissions, you're going to get notified. All that is already built in.
Because there are a lot of people out there using multiple tools like Nagios or Datadog and things like that, and bring them all together to make this work. So with this you can cover all areas.
Yes, everything's in one place, and there's it's like 100 or so different technologies we can monitor straight out the box. And yeah, it's all pluggable, so if you want to push in some custom metrics, you can do that. So Prometheus, for example, is really good for collecting custom metrics. So say we go back to our e-commerce example, and you wanted to know the average value of a shopping cart. Well, that's payload data. We don't do that. We're all about the performance. But so you could write a Prometheus collector to get the value of the shopping cart upon checkout, and then we will import that Prometheus data. You don't need to run a Prometheus backend. We'll just go and scrape that Prometheus endpoint. So Prometheus is great for that sort of business data, but you don't need to manually instrument your code to collect everything. Our automatic instrumentation observability does that for you.
Any questions from anyone else? Yeah.
Sorry. What about sensitive data like credit cards and things like that?
Yeah, we don't collect any payload.
But
data.
if you did write these plugins, it would be on you.
Yes, yes. If you're crazy enough to write a Prometheus collector which scrapes credit card information, then yeah, that's
no, that's a good answer.
But things like there's certain information, for example, like JDBC connection strings, which would have a password in. We know about those, so that would be masked.
Yeah. Okay.
And through GDPR for the end user monitoring, we mask the last bits of the IP address. So we collect the IP address, we do the GRIP lookup, so we know where they're from, but we don't actually collect a unique IP address because that's uniquely identifying. That goes against GDPR.
Good.
I'm assuming integration with notification tools like PagerDuty, those kind of things.
Yes, there's a whole load of those. So you have alert channels. There's a whole bunch there that you can go out via, and you've got the good old generic webhook, which pretty much covers most things. So yeah, there's some standard
You can't watch it 24 hours a day, can you?
Yes, so this is where it's going through to it's going out to PagerDuty, or VictorOps, or somebody like that, or a Slack channel. Then the appropriate people will get notified. They can log in, and the alert you get has a deep link in it, which brings you straight back into Instana in the right place. So yeah, they're pretty easy to set up. Yeah, you got your infrastructure view. We had a look at previously. You can just mouse over that, and everything's indexed, so we know we're looking for something. So, oops, if I could type. So I know I've got a payment service running somewhere. Where is it running? Oh, look, there it is. I can get straight to it that way. So, and again, same thing with Kubernetes labels, annotations, Docker labels, annotations, all that data gets indexed. So if you're looking for something, it's very easy to find it.
Well, we scout the whole setup so for our experts to look at things.
Okay.